In the prior section, we use a library called scikit-learn to do machine learning, specifically linear regression. Now, scikit-learn is a wonderful library and it's used throughout this entire course and other follow-on courses. And it does have linear regression, but it's lacking in some dimension. One of the many dimensions that is lacking is that it doesn't have a rich set of statistical tests and diagnostic, right? That's usually built for linear model. A library that does have that is called Statsmodel. There's the whole module, and I'll walk you through the code. Now, why is this important? Well, what we saw earlier was, R squares being one of the measure of fitness, but there's a whole bunch of other statistical measure, such as looking at the coefficient, the beta, and confidence interval, t-stats, a whole bunch of other stuff. If you or your team or your boss are more statistically oriented, they would want some of those statistical measures, which is currently not offered in the scikit-learn. Or if you're learning stats yourself and you want to look into those model diagnostic tools, they would not be available in scikit-learn. That's why I'm introducing the stats model module for you, so it can give you more statistical flavor and statistics about the model. Right? Okay, let's jump right into it. So it's relatively simple. All you have to do is say import statsmodel.api as SM. That's just my shorthand, and then import the usual NumPy and pandas library. Okay. So let's try to replicate what we did earlier with scikit-learn, but now using the Statsmodel module, right? Here again, we read in the file as a data frame, panda data frame, right? And did the head, so you can see all the field, price, age, kilometer, which is a measure of mileage, field type, and so forth. Okay. Now in Statsmodel, in order to make it statistically rigorous and correct, we have to use a constant. Okay. So before we get to that point, so y, which is the dependent variable, is equal to data frame dot price, right? Because you're trying to predict price, versus the x, or the predictors of feature, is the kilometer, which is the mileage, right? Then you say x equal the model, you add constant to that model, right? So when you look ahead, you see that constant is 1. It's initialized to 1, but the constant will not be 1. It depends on how the regression model figures that out. Now, in the scikit-learn linear regression model, we didn't have a constant, right? That's kind of interesting, though, if you think about it, right? So what it's basically saying, if you remember correctly, and I'll go back to this here, we did price and kilometer, right? So a constant would mean that it would intercept somewhere in the y-axis, which is y. We'll find the answer here. But here, that there's no intercept, right? It just try to fit these points, right? But from a statistical standpoint, a lot of statisticians like to look at want to account for the constant term of the intercept as well. Okay, so now to run it, it's actually very simple, right? We call the sm.ols. OLS stands for ordinary least square, which is what a linear regression is. The reason it's called least square is if you remember the way regression is set up, is that you draw a line through your points and find that the line that minimize the square distance between your line and the point, right? And that's why it's called least square, right? Okay, and then you put in the y and the x. You do a fit function, right, which is a standard in all the libraries. You set up the equation and then you have to fit it, right, with the actual data. And then here's the summary. Now, I really like this summary a lot. It has a lot of statistics, a lot of information, in addition to just the beta that you saw in the scikit-learn model, right? Here you can see, there was 436 data point observation, right? The residual was 1432. The reason why there's two difference is because if you remember from your stats class, or I can tell you now, the beta, which is the variable x, has a kilometer. That's 1 degree of freedom, and the intercept is the second one. So you lose 2 degrees of freedom. That's for you minus 2 here, right? And then in addition to the R square, you have the adjusted R square and R square, and you notice here it's slightly better. 325, and in the other one it was 305. So, we improved by 2% because of that intercept, right? There's also other useful things. It's just as F-stats tells you the total nature of the regression. And then more importantly here, you have the constant, right? So you see this value here. If you don't want to multiply it out, you can do estimate.params, which shows you the parameters. And the parameters here is that the constant is 14,508, and the kilometer is negative 0.05517. Because there's an inverse relationship, right? The older the column, the cheaper it is, right? And here you can find the standard error and then get the t-stat, right? As you remember, the t-stat tells you how statistically significant your parameters are. Here it says that both of them are highly significant because the t-value is very high, okay? And so some people use p-value, and the p-value here is very small, which is a good thing, right? And it also gives you the 95% confidence interval between the constant, between your coefficient, right? So on the upper range and at the bottom range, the upper limit and lower limit for both the constant and the kilometer betas, right? So you have that 95% confidence interval, right? And then since this is, as I say, this is not a math class, this is not a heavy stats class, I just want to give you a flavor. There's other stats that may be useful if what you do is more statistically oriented. Such as skilled, kurtosis, it tells you kind of the shape of the distribution. Dublin-Watson talks about like serial correlation and stuff like that. So I just want to really show you that there's other libraries besides scikit-learn. Scikit-learn is very good with hardcore machine learning. Linear regression, though technically it's part of linear regression, but it has a long history from the field of statistics. So if you are going to run normal linear regression, you should then use the Statsmodel, which is, I think, has a more richer set of features for standard statistical model. Okay, so hopefully you enjoyed that and apply Statsmodel when the need arises. Okay, thank you.